Hello. This is Jurat Abraham with another video, and in this one, I'm going to show you guys how to use the TI-84 to solve normal distribution problems when asking the probability of a given mean. In this example, I'm going to be using problem from this book, Probability and Statistics for Engineering and the Science. And I'm going to be using problem 33 in chapter 4. So here we go. The problem is like any other engineering or science textbook, they always give you a background story of the problem. In this case, talk about mopeds, small motorcycles with an engine capacity below 50 centimeters cube, and they are very popular in Europe because of their mobility, ease of operation, and low cost. The article procedure to verify the maximum speed of automatic transmission mopeds and periodic motor vehicle inspection. That's what they got that from. So please don't get confused or worry about with all this background information. The important stuff starts right here, pretty much right here. Oops. Oh, right here. And that's when it says describe a rolling bench 10 test for determining maximum vehicle speed. A normal distribution, that's important, that's what I have highlighted, with a mean value of 46.8, that's also important, and a standard deviation of 1.75, that's also important. It's postulated and is considered randomly selecting a single such moped. Random selected is also important because that shows or prove that this is a normal distribution problem, because that's one of the requirements. To be a normal distribution needs to be random. And so let's go straight to the exercise. So I wrote down my mean, my standard deviation. So like any other distribution problems, we have to do our graph here. So let me go ahead and adjust my windows here. Let's see. Let me make this a little more comfortable. Here we go. Zoom out a little bit. All right. So I'm gonna go ahead and make, like I said, I'm gonna make my bell curve. There we go. There we go. It's not a perfect one, but it'll do. So my mean is right here. That's the 46.8. And then I have a first standard deviation, which in this case will be 46.8 plus the standard deviation of 1.75. That will be 48.55. My bell curve is not so perfect. But not, sometimes not as easy as you think. And the whiteboard, regular whiteboard is much easier. So what I'm gonna do, I'm gonna do the line in the bottom first, the x-axis. All right, so plus again 1.75. That's 50.3. And then one more time, 1.75. Enter. That's 52.05. And on the left side, we're gonna have 46.8 minus 1.75. Now some of you guys probably said like, man, can you just go ahead and just give us the procedure to use the calculator? Yes, I'll get there. Don't worry. It's just first thing is first. We need to do the graph so we at least know what's going on. Okay. And before I forget, please don't forget to subscribe, like the video, and comment below. Okay. All right. So let's see. Let's go one more subtract. 1.75. Because I mean, what's the point of giving you guys the answer if you guys don't know what's really happening? Okay. Okay, 43.3. And one more time. There you go. 41.55. Okay, and then we do this. There you go. Bell curve right here, bell curve right here. Okay, cool. Yeah, I know it's not so perfect, but anyway. All right. So, um, the problem, the letter A. What is the probability that the maximum speed is at most 50 kilometers per hour? So 50 kilometers per hour. Where is 50? Okay, here. Okay, somewhere over here. Okay. So pretty much they want to know the probability that the most will be right there. So probability is anything that's inside the bell curve. So they want to know what's the area inside here. Okay. All right. So how do we do this in the calculator? Well, like either use just like you were using the table, and you read it from left to right the table. The same thing works with the calculator. Now there's a few calculators really like one of the new models that gives you the options. But I'm just gonna be working with the the more typical calculators, uh, which has the reset from left to right. So pretty much what I'm gonna be doing is leave it from left to right. So I'm gonna find the probability from the left side to the right side, which pretty much that's what they're asking us. Okay. All right. So to do that, first we need to go to second. Actually, let me clear this first. Go to second, the vars, which is going to be distribution up here in blue. And then we're going to choose normal CDF. This is a normal distribution problem, hence the name normal CDF. Okay. So we're going to go ahead and do enter right there. And it's going to ask us what's the lower, the upper, the mean, the standard deviation, and then paste it. Okay. So we're gonna go now. If your calculator doesn't have this format of as you can see here, you can go ahead and do first second quit because maybe you need to adjust the settings. So second quit to clear this, then go to mode and go all the way down. And here where it says stats wizard, be sure it's on and press enter, or select on and press enter. Okay. And then go back to second distribution. And you will go back to normal CDF, and they'll give you, oops, sorry, start again, second distribution, there you go. I'll give you like this. Okay, now if for those who have a same TI-84 by another version or a TI-83, you might have seen something, your calculator might not give you like this. It might give you to, for example, and no more CDF, and then they give in parentheses, almost like the one I had before. Let me show you what I mean. Because I'm gonna change. I have to change my mode to be second distribution. And as you can see, the distribution gives you all the different distributions. You have your normal distribution, your t distribution, and a bunch of other ones. But in this one, we're working with normal distribution. Okay, you might have it like this. If it shows up like this, pretty much the first number you're gonna plug in is always gonna be your left boundary and your upper boundary. I'm sorry, yeah, your lower boundary, your upper boundary, and your mean and your standard deviation. Okay, pretty much the same order that it has when you go to the mode or the setting and you switch it to the wizard. Okay, and this just to be sure, second quit, clear, and then second distribution. All right, and then you go back like this. Okay, the lower bound, the upper, the mean, and the standard deviation. Now, my lower in this case, it needs to be a number lower than as lower as I can do here. So as you can see, pretty much on the third standard deviation right here is 41.55. So any number lower than that will work. Oh, I'm sorry. Let me rephrase that. Any number way lower than this will work. For example, 0 will be a good example. Okay, decent example. Me personally, and many professors would do this, just to keep it safe, let's make it a negative e to 99. Now, what is a negative e to 99? It's pretty much saying that it's a 99 has like the decimal point of a number will be moving to the left 99 times. Okay, uh, so that's what that means. I'm sorry, to the right 99 times. So because we have a negative e, so pretty much saying that you have a 1. Maybe I should have done it like this for explanation purposes. I forgot what's the e. Sorry. A goes by the comma. 99. Okay. So like a negative, I don't know, quadrillion or something. All right. The upper, that's what it has to be. It's going to be the number they gave us on question A, 50 kilometers per hour. Because I want them to stop at 50. The mean, the one they gave us, 46.8. The standard deviation, the one they gave us, 1.75. Okay, so I'm just using the number they gave us. Press enter again, and it's that. So that means that for the maximum speed is at most 50 kilometers per hour. That means there's a 0. Let me put it, okay, a 0.966 3 or a 96.63% probability. So that's what that means. That means the probability of the maximum speed to be at most 50 kilometers per hour is 0.9663 or 96.63%. Depends on the professor, depending on the book. You'll see if you need it's either they want it to have in percentage or in decimal. Okay. All right. So let's go ahead and do the next one. And again, please do not forget to subscribe and like the video or dislike and comment below, because that's the only way I know if you guys need what type of videos you guys want me to make, or if you want me to make any more videos. Okay, so please comment below. All right, and problem B, saying almost the similar stuff that we just did right now. So let me just erase some of this stuff here. I don't need this. Let me erase this. Okay. Erase this really quick. Right. Now they're asking you, what is the probability that the maximum speed is at least 48 kilometers per hour? So at least, let's talk about the other way around. 48 is somewhere, or 40, yeah, it's about right here. Oh, somewhere right here, okay? So at least they talk about this side of the bell curve. So they want to know what is that probability, either in percentage or in decimal. So since, again, we go to the calculator, be sure this, we have this nice and clear. We do second, bars. Remember, like distribution. So pretty much anything that uses the blue bottom here is for the blue commands up here. The green is the green commands, which in this case are the letters. So now we go to normal distribution. Normal CDF. And then in this case, now the lower boundary or the lower bound is a little bit different. Oh, it's different. In this case, it's going to be the giving number to give us at least 48. So it'll be 48. The upper is going to be the maximum. Again, I could use 60 or 100, but it's best recommended to put a really large number. You can also do it just like this, or like just do 1E299. Excuse me. And I'll keep my same mean and standard deviation. Just go down here, press enter, and there it goes. So is 0.2464. Yes, or 24.64%. Okay, so that's the probability, and the probability that maximum speed is at least 48. That means to be at least at 48. That means it's either 48 or more. Okay, so that's the probability, which is pretty much the area under the bell curve. That's I guess that's the calculus behind it, or the math behind it. Okay. Now, the next problem, it says, what is the probability that the maximum speed different from the mean value by at most 1.5 standard deviation? Okay, see now, what is the probability? Okay. What is the probability that the maximum speed different from the mean value by almost 1.5% standard deviation? This problem, which I'll be honest, I didn't practice this problem because I was more concentrated on the calculator part of these two problems. What is the probability that maximum speed different from the mean base by almost? Oh, okay, so let me erase this thing right here. Okay. All right. Okay. Different from the mean. So most by most at most today. So standard deviation. This considers. So here I'm gonna write down the standard deviations. This mean starts at 0. The first standard deviation, the second standard deviation, the third, and in this case here on the left, it goes -1, -2, -3. They still consider the first standard deviation, the second, the third, but going towards the left on the negative side. But they want 1.5, so 1.5 somewhere over here. 1.5. So first I need to know what is 1.5 standard deviation for, when I give information. So what I'm going to do first, I'm going to go ahead and calculate. So in this problem, we need to use the what you call the formula, the z-score formula, which equals the value minus the mean or minus the center all over the standard deviation. Okay, value minus center all over standard deviation. Okay, this formula is going to help us to find the value. We're looking for the value. Okay, we're missing the value. Okay, and this problem really what it's asking us is what is the probability and what is the probability that the maximum speed different from the mean value by almost. So I believe they're asking for this one right here, to be honest, because I didn't look this one up. I'm sorry about that, guys. Okay, so different, yeah. So they want to subtract this number minus this number. Okay. Okay, so we can do. Let's see. There's different ways to do this actually. I don't know if I should show you guys this way or show you a different way. You know, just for the purpose of, you know, showing you guys how to do it a different way. Yeah, I'll show you guys how to do it a different way. So in this case, what I'm gonna do, I'm gonna go ahead and instead of using the actual values, I'm gonna use the z-score values to solve this problem. Since we already know that the z-score value of the mean 46.8 is 0, and they're already giving us the z-score of 1.5. So what I'm going to do is this. I'm going to go back to the calculator, which turn this on, clear this, to second distribution, normal distribution, and they want my lower is going to be 0 because I'm going to be using the z-scores value. The upper is going to be 1.5. Now, if I knew the upper, what does 1.5 really means and their values, I would plug those in. Okay, so this is a good example of finding the area between 2 points, by the way. Okay, or the probability between 2 points. Okay, so now my mean, I'm gonna have to readjust it to 0, and my standard deviation to 1, because those are the z-score values of the mean and the standard deviation of any normal distribution problems. Okay, I'm just gonna press enter, and there it goes. So the probability inside here is 43.32% or 0.4332. Okay, all right. So problem C, what is the probability that maximum speed difference from the mean value by at most 1.5 standard deviations? Okay, let's see. I have to be careful with these wordings. So pretty much this means the maximum speed difference, so maximum speed in between from the mean value by at most 1.5 standard deviations. So pretty much asking you, so the standard deviation or the z-score of the mean 0, then we have 1 standard deviation, 2 and 3, and going towards the left we have -1, -2, -3. So 1.5 is somewhere over here and over here. So pretty much they're saying that what is the difference of the standard deviation, the probability difference between the probability of the difference between these 2 points. This is a good example of finding the probability between 2 points. All right, so we're looking for something right here. Okay, now in this case they're giving us the standard deviation, not the actual values. So what we can do is convert the standard deviation to values using this formula, z equals z-score equals the value minus the center over the standard deviation. Okay. Oh, and symbol to be z equals x bar minus the mu over sigma. Okay, which will be that if we use the 1.5 and the positive one, it'll be 1.5 equals x bar minus what's it 46.8 divided by 1.75, and we just solve for x and we get the value. We plug into the calculator. Oh, I'm sorry. And then we do the same thing with the one on the left, which will be a negative 1.5. And then we get those two x values and we plug in the calculator. But what I'm going to do, instead of doing that, I'm going to just use 1.5 so you guys can see that you can also use the actual z-score values, the z-scores. I'm sorry, not z-score. Excuse me, the z-scores to solve this. So first, I need to zoom out a little bit. Let me zoom out. Give me mouse. There it goes. So I can have some space here. Okay. So what I'm gonna do is I'm gonna go ahead and plug in, because I know this side right here is gonna be my negative 1.5 and this is my positive 1.5. So I'm gonna do be sure we quit this. Oops. And clear to second distribution, normal distribution, and right here in the lower bound I'm going to put negative 1.5, and my upper I'm going to put 1.5. My mean and my standard deviation I keep it 0. Yeah, I was practicing right before making this part of the video. And 1. Okay. So pretty much that's what it's saying. They're saying what's the probability of the maximum speed to be the difference of the mean at most 1.5. So 1.5 standard deviations. Okay. So when we do that, you get this. So pretty much the probability is 0.8664 or 86.64% probability for this to happen. Okay. All right. Well, that's it. I hope this video helped you guys out. Please subscribe, comment below to see if I need some improvement and ideas, and don't forget to like or dislike. Okay, and also tell your friends, guys. Okay. All right. Bye bye.